Good afternoon. Oops, it's a little loud. No, it's fine. It surprises a little. So thank you for coming in our talk. Our talk is about MySQL and Vitess and Kubernetes at HubSpot. So we will talk about what we have, what we learned, the mistake we made, and the traps you should avoid if you're doing things similar to us. So when I say we have something, or I present numbers from HubSpot, these are like HubSpot data. When I say I think, or in my humble opinion, it's me, it's not HubSpot. So like, you know the drill, right? So my name is Jean-François Gagné. I define myself as a system engineer and a MySQL expert. I am not a Kubernetes expert, but I've been working with Vitess and Kubernetes since I joined HubSpot 2.5 years ago. And I've been seriously working with MySQL since 2014, when I started to talk at this conference. And I have my co-speaker.
Hi, everyone. I'm Shweta Narayanswamy. I head the data infrastructure team at HubSpot. That includes not just the MySQL infrastructure that we'll be sort of zeroing in on today, but also our HBase infrastructure, Elasticsearch, Kafka, Zookeeper, and essentially all of the critical data for HubSpot is managed, and we're the caretakers of that data. All right, so we have the privilege of being your first talk after lunch. So we're going to keep it really fast-paced. So we'll give you an introduction into the technologies we use. As Jean-François mentioned, it's Vitess, Kubernetes primarily. We'll zero in on our infrastructure. We'll talk about how it's set up today. And then our learnings and blind spots we hit and how we handle our challenges. So that's the sort of agenda. Okay. So that quote you see there is a quote from a member of our team. And as it says right there, we run thousands of MySQL databases. We support 1,500 plus engineers at HubSpot. And like I mentioned earlier, we support major portions of the product, actually all portions, I think, of the product, and we sleep at night. So that last part is testament to all the sort of tooling and automation that we've built and the choices we've made for our infrastructure. So really what we strive for as a team is a high-class developer experience. So we want to enable self-service provisioning and really quick development for our product teams. We're in a business that we want to run quick as the market changes. And we as the data infra team don't want to be the blockers for our product teams. So a little bit on how we operate. HubSpot's mantra is about small autonomous teams. And when I say small, we're talking about 3 to 4 members to a team. And the same is true of data infrastructure as well. For MySQL, we're a team of 12, split into orchestration, services, and performance. Orchestration, as you can imagine, they take care of the resiliency of the system. Services, they build all the developer self-service technologies, and performance is self-explanatory. And engineers from all the teams balance the role of helping our product team. So whether it's Q&A or looking at critical issues as they come up. So things we've gotten right, we believe, are the ease and reliability of provisioning new key spaces. It's a click of a button. So we want to outsource that as much as possible and not have to be bottlenecks when that needs to happen. We built a ton of tooling. I won't steal Molly's thunder. He's going to talk about our developer tooling in a talk right after this one. So go to that one if you want to learn more. And we've built workflows and automations to handle upgrades. And that's something we expect to use continuously, because as you can imagine, you finish one upgrade and you're thinking of the next one already. And so in order to ease this process pretty much across our data infrastructure products, but specifically on MySQL, we focused on that. There's always more to do. We're looking to raise the bar continuously. We are continually working on automation. Self-service resharding is something we're working on. We are making continuous improvements to our operator as well. Okay, so I'm going to give you a very brief overview of Vitess and Kubernetes. If you went to a couple of the talks yesterday from our colleagues at GitHub and Vitess, you probably got an overview already. So I'll make it quick. Vitess really provides all the nuts and bolts to run MySQL at scale, and that's what we use it for. So we rely on the scalability with sharding and so on. We rely on the optimization, data optimization features, connection pooling, and we also use the operational features like reparenting and backups and so on. So some very key specific terminologies you need to be aware of for Vitess. Really three basic things is shard, keyspace, and reparenting. A shard is essentially a subset of a keyspace consisting of the MySQL primary and its replicas. The keyspace is the logical schema. And the action of reparenting is changing the primary for a keyspace shard. And you can read sort of the details. The slides and the recording will be available after, as I understand it. So you don't need to worry about taking notes or anything. Okay, this just, again, pictorially shows you how Vitess sort of flows. The application sends the queries to VTGate that routes it to VT tablet, which is the sidecar for MySQL. And on the control plane side, you've got the GUI, which is the VT admin, the API server, CTLD, and the orc as well on the topology side. This diagram just shows you that multiple apps go through a single VT gate. So Kubernetes, again, very popular. Most of you are probably aware of what is Kubernetes, so I won't delve into too much detail, but it's a platform for managing containerized workloads. Again, two key pieces of terminology there. Pod, that's a scheduling unit, and replica set is at any time, Kubernetes guarantees that there's a stable set of pods running at any time. Okay, so now we're going to shift gears and talk about our infrastructure. So we'll give you a sense of what we have today, right? It's, again, always in a state of evolution, but we feel like we've hit sort of a reasonable milestone in our infrastructure at this point. And then we'll talk about our journey. So it's sort of a story format. And the last part you see here called Hublets is Jean-Francois PC will take over from there. He'll talk about how we went to multi-region deployment. Okay, so we run on AWS. We have 2 production Vitess Kubernetes clusters. You can read there. We also have environments for development QA. We use EBS for snapshots. We also do backups in S3. And this gives you sort of our versions that we currently run. So we are on Vitess 14 now. We were on 5 until just a quarter ago. So that was a big milestone for the team. We just moved to 14. That was a big effort, as you can imagine. And that's when we built a lot of our tooling around upgrades. We run Percona Server 5.7. And we, of course, will eventually get to 8 on that. We run, that gives you the next set is really about our scale. We run 800 plus production key spaces. Each primary has at least 2 replicas. And then you can read about sort of the config that we run with on persistence and so on. Okay. So tooling, again, as I mentioned earlier, this is something the team takes very seriously, and it's a critical part of the day-to-day work that we do. So we handle about 100 plus schema changes or migrations per week. And to give you an overview of our tooling, we have our own fork of Ghost and Vitess. And like I mentioned earlier, we use the Percona Server, extra backup, and the toolkit as well from Percona. And again, plug in for Molly if you want to know more about our tools. Yeah, it's needed twice. All right. So why Vitess and Kubernetes? Why did we get to where we are? So again, back to self-service. Our goal was to provision a DB in minutes, 0 manual actions. We also wanted resource efficiency, so right-sizing our containers, better backups, and finally scale, right? That was a big piece. We were getting to a point where our MySQL DBs were really pushing the limit. And in fact, there were cases where we were telling our internal customers wanting to use MySQL workflows to maybe look at HBase or a different data store altogether, because it was not sustainable at that level of scale. So we really needed that scale, and we're happy that with our choices at this point, we have achieved an order of magnitude of scale versus a previous system that we had. We have all but eliminated manual actions for operational work using our Kubernetes API automation. And then we use Vitess heavily for our operations like backup, restore, and topology management. So just to center you back on where we are with the story, where we migrated to Vitess Kubernetes. We ran first in the AWS US East region, and we still have our own Kubernetes operator and automation tooling. So the rest of the story is going to come from Jean-Francois.
Thank you, Shweta. So Shweta presented us the migration into Vitess and Kubernetes, but at that point, we are HubSpot only running into AWS East 1. And obviously, we have European customers that want their data in Europe. So in 2021, we released what we call the European Data Center. So we spawned a whole copy of HubSpot in Europe in what we call the EU1 hublet. So each of these instances of HubSpot is a hublet. So what we add became the NA1 hublet, and then we have a new hublet in Germany in EU1. So this means that we multiply the number of Vitess cluster by 2. We multiply the number of Kubernetes cluster by 2. And we also have a lot of new key spaces, or actually a copy of the important key spaces for running HubSpot in EU1. So this is about 75% of our key spaces. The rest is for internal usage. And there are two interesting things we did for hublets. So we want unique IDs across hublets. And these are two different Vitess clusters. So we build what we call vtickets to do that. I will talk about this in the next slide. And also, we need some global data. So some data need to be on both sides, and it needs to replicate. So we only modify this data in NA1, and it self-replicate into EU1. Most of you familiar with replication can guess how it is. It will be presented in 3 slides. So about vtickets. So vtickets is an extension of a concept that already exists in Vitess. So there's already a feature called vSequences to allocate unique IDs across shard. So we extended that. This is something that works at the VT gate level, but we build vtickets at the VT tablet level. And we think it's quicker, more resilient. And the side effect of this, though, is that IDs on different shards might be allocated out of order, or on different hublets might be allocated out of order. So a little on how it works. And if you want to know more, there's a full blog post about this. So the next ID lives in Zookeeper. We have a vticket service that connects to Zookeeper to retrieve the next ID. and the VT tablet calls this vTicket service. So it really isn't that complicated. What we don't see here, though, is that there are many of these VT tablet for sharded environment that call the same vTicket service. And there's another system on the other continent in Europe that also does that. So the vTicket service, there's two levels. There's one local and one global. There's caching and prefetching happening at each layer to allocate IDs and to be resilient to transient failure. And also, the cache in the VT tablet allows us to allocate IDs very quickly without having to go to a centralized server. So this is basically our design of vTickets. Cross-oblet replications. So the tables we need to replicate, we put them on a replica with replication filters. We have a cron job pushing bin logs in S3. We have a cron job applying bin logs from S3 in Europe. So something that is very, very simple until you hit a MySQL bug. MySQL bin log pipe MySQL fails with GTID replication filters and timestamp default. It's unfixed as of 2023, and it's a 2 years old bug. So nobody from Oracle here, but have a look at this. So if you do MySQL bin log pipe MySQL and you have replication filters and these, have a look at this. Sometimes it doesn't do what you would like it to do. So just a reminder of where we are in the presentation. We've introduced Vitess and Kubernetes. Now you know what we run, what we have. And so now the next step is about more information about what we think and the things we think work well and do not work well in Percona Server, MySQL, Kubernetes, and Vitess. So Percona Server, who is running Percona Server? Almost everyone, so you know what it is. So there's a few improvements in Percona Server over Oracle MySQL. These improvements come with a drawback, though. So these improvements that we liked a lot are the extended slow log in Percona Server with a lot of InnoDB insight. There's log-free extra backup. So there's an extended feature in Percona Server to allow extra backup to do log-free backups. And Percona Server has a lot of bug fixes over MySQL. So bugs that are still open in MySQL are fixed in Percona Server, and we're going to come back to these in the MySQL section. But when you introduce new features and you fix bugs, sometimes you introduce regression. This is normal. We've found a few. I've blogged about a few of them, but this is part of running software that works a little quicker than upstream. Sometimes it introduces regression, but Percona fixes them very quickly. So we're very happy that Percona is making MySQL better with Percona Server. So MySQL at HubSpot. So we run with slow log and general log fully enabled with one slow log query threshold that is global to the database, to MySQL. It can be different per key space, but we usually use 100 milliseconds as our slow query threshold. Like everyone, we use comments in queries. We have a love-hate relationship with this. It allows a lot of things, but I wish there was something better. Everybody's been doing that for 15 years, and there's still nothing more interesting. There's a few building blocks in MySQL, and I feel it could be better. And we look forward for the slow query time per query in MySQL 8. In MySQL 8 as the feature of setting the slow query threshold per query in a comment. So we're really looking into forward to this to be able to have a more granular slow query report. So there's a lot of things that are good to know that I will mention later in the slide. But one thing, Oracle is doing a relatively good job at improving MySQL. A lot of people have complained about things in MySQL 8 that are not backward compatible. You cannot roll back. But we need to remember that it is us, users, that asked Oracle to release more features more quickly. So this is what they did, and this is the cost of this. So we need to live with what we asked. And things is evolving. We've all heard of the new LTS release model from Oracle. I'm looking forward to learn more about this because it looks like this will make this process of improvement a little better. So Oracle is doing a good job about listening from us and doing new things. However, Oracle is saying that they're not going to support semi-sync anymore. And that makes me very sad because HubSpot runs with semi-sync. We're not planning to go anywhere else. And we like semi-sync. It works well for us. Oracle claims it doesn't work well. Well, it's not our opinion. It works well for us. And group replication, from my point of view, is too complicated. And simpler is better. Like, simpler allows to troubleshoot stuff. More complicated, like you're not able to understand the system, and it breaks in creative ways. So if you also like semi-sync, please join me showing your love to semi-sync with the love semi-sync hashtag on Twitter, LinkedIn, or wherever you want. These are 2 tweets and LinkedIn posts that I did this morning. So multi-threaded replication in 5.7 is useful for replication lag, but there's a lot of rough edges. One of them was a deadlock that was happening, and I reported this bug many years ago, and it's finally fixed thanks to a patch by Percona. So Percona found the bug causing deadlock and contributed the patch. So very, very good job, Percona. Thanks to Percona, we're able to run multi-threaded replication now. There's also another deadlock that if you change the read-only status of the database at the same time as parallel replication is working, it might deadlock. And so there's a very easy, quick self-healing. You just kill manually the SQL thread and you start it back and it works fine, but it's very annoying because we write to replicas, and so we like the security introduced by super read-only. So to be able to write to replicas, we disable read-only, super read-only, we write to the replicas and we re-enable it back. And so this is a little annoying. We have some workaround around this, but this is annoying. And yes, super read-only is useful. We would wish that we would have to disable super read-only at the global level when we need to write to a replica. So I did a bug report on this. It's a feature request I did last week. If you like it, click the Affect Me button so Oracle knows that it's useful to all of us. So a few other things to know. So we run with sync bin log equals 0. Everyone in the cloud probably runs like this because a round trip to the storage is long in the cloud. It's not local disk anymore. You need to go through the network. And on bin log rotation, MySQL flushes the bin log at that point. And if you have a 1 gig of RAM that needs to flush to the disk, it takes time and it stalls transaction. So commit might stall at this point. Vadim saw this a few years ago. It's still not fixed. And I would claim that MySQL will not be cloud ready until things like this are fixed. Until MySQL is friendly with running with sync bin log equals 0 and TRX commit equal 2, MySQL is not fully cloud friendly. We all know about problems with foreign keys. There are also very interesting problems with generated columns that there are bugs we hit that are triggered by a Vitess resharding. And this is a data corruption bug on replica. The data on replica ends up being null instead of being the right data from the generated column. It doesn't affect 8.0. It affects 5.7. It was reported in June of 2022, not fixed. It looks like 5.7 went end of life some time ago. So it's not super cool that this is not fixed. We do not use generated column in our sharded key space because of this bug. So this is a feature we cannot use right now because this bug corrupts our data when we reshard. And there's other annoyances about things that are there for 10 years and are not improved. I have a blog post about this one. But performance schema is super useful. Molly will probably talk about this We gather a lot of data from the table, even statement summary by digest. It allows you to know what's running on your system, which queries are running. We have a script called PS collect digest that takes a copy of that table every minute. And by diffing, these are all counters incremented when things happen. And by diffing 2 copies, we know what happened in the interval. So this is super useful. And we save these copies in MySQL itself. This is why I'm writing to my replica. So there's a table in MySQL. I do insert select to get a copy, and I'm writing on my replica with this. And every time that I do that, every minute, I need to disable super read-only and re-enable it again. There's a few annoyances about the way query digests are generated. They're listed there. And there really is something about rows examined in MySQL. Rows examined is not what you think. It's not the number of rows examined by InnoDB. It's the number of rows returned by InnoDB to the MySQL server. So when the server queries InnoDB and it returns nothing, there's 0 rows examined. Even if you looked into a B tree and you looked at somewhere in an index, this is 0 rows examined. So a query like this, where a value in A1, A2, AN, and B is like a lot of other values. Imagine I'm doing here a Cartesian product 10 by 10. This examines 100 rows. If it returns 0 row, there will be 0 rows examined in MySQL. So this is a very bad name, and you should know about this when you look at rows examined and everything that is claimed rows examined in MySQL. So who uses InnoDB table compression, row format compressed? So, okay, so a few users. We also use that to save disk space. All our tables are key block size 8. This is a decision that happened before my time. But sometimes you don't save any disk space with this. You just waste CPU. And you could maybe save more disk space by using a better key block size. So I would claim that it's better to never use compression and only use it when you need it, especially that this feature is very complicated to understand. It behaves very differently. There's weird behaviors and many unsolved bugs. There's a bug in buffer pool metrics that goes wrong because of InnoDB table compression that hasn't been fixed in 2011. Valerie has a full blog post about this. And there's a regression in 5.7.27 about counters. This was introduced in 2019. I saw it and opened a bug in 2022. So it looks not a lot of people are looking at these statistics. These are super useful. And from when we upgraded to a new version there, you can guess it was in April 2022. We were not able to see these statistics. When I prepared this talk, this wasn't solved. Like a patch was contributed, wasn't solved. So I rage opened the bug to Percona, and they fixed it. So it's fixed in Percona Server. A bug not fixed in MySQL for a year has just been fixed in Percona Server in a week. So thanks again, Percona. And there's a crashing bug in InnoDB table compression. If you roll back a transaction on very specific rows, it will crash the server. Not all rows, very specific rows. And if it's the Vitess query killer that kills a query that ends up doing a rollback, it means that it's your application that crafted a query that make your server crash because of a query killer. And if the application sends the new query to the new replica after orchestrator promotes something, it will crash again. Very, very annoying. There's a potentially cascading failure here. Yes, MySQL doesn't come back up because on crash recovery, it will do the transaction and roll it back again in crash recovery. So it will roll back what it tried to apply and crash again. So it's an unrecoverable data corruption. And because of that, right now at HubSpot, we are decompressing all our tables, except maybe a few that will stay compressed. So there's two learning here. Like, this feature is interesting to save disk space, but use it only when you need it. And if you haven't tested your cascading failure prevention recently, well, maybe a good idea to test this. So Kubernetes at HubSpot, historically, we were running into Mesos for our workload, not MySQL, I think, but most of HubSpot was on Mesos with a home-developed scheduler, which was called Singularity. Kubernetes is slowly replacing Kubernetes. So Kubernetes is slowly replacing Singularity, and our MySQL is running in Kubernetes. So it's great to run MySQL in Kubernetes. Like, the things you need to do often are automated, but the things that you don't need to do often, if they're not automated, you will have automation fighting you, and we'll talk about this a little. And then you need also to not bring concepts from VMs into the container world. Like, the container world is different. You need to think in terms of containers. Some people are writing FUD about Kubernetes. Like this guy doesn't look super comfortable on the ORS, but we are super comfortable on that ORS. Like, this ORS for us is not like, this ORS is misbehaving, but this is not our experience with Kubernetes. We don't agree with this. HubSpot is successfully running Kubernetes, is successfully running MySQL in Kubernetes like for 5 years in production, and it's quite a smooth ride. You agree? Yeah, so Mali has been there before me at HubSpot, and he is very happy with Kubernetes. And HubSpot is running other stateful data set in Kubernetes. We run Zookeeper in Kubernetes, and we run HBase on ARM in Kubernetes. So we're fully committed to Kubernetes. So an example of a VM concept that we brought into our own operator. We have our own operator for MySQL. So we have this concept of performance class for a key space, medium, large, X large. But we thought in terms of VM, in terms of CPU and RAM. We allocate CPU and RAM to these pods. And then from that, we compute how much RAM we allocate to MySQL, to the buffer pool and other things. But this is backward. This is thinking in terms of fixed RAM and making MySQL work in this. We basically build a VM system. We should think in terms of MySQL service. A MySQL service should have a certain set of RAM, and from this, we should forward compute the amount of RAM allocated to pod. So like this is a shift, but like I think it's interesting, and we are moving away from this. Like, because right now, when we increase max connection in MySQL, it steals RAM from the buffer pool. And then the behavior of the system changes. We don't want that. If we increase max connection, we just want the container to use more RAM. We don't want MySQL to have less buffer pool. I'll skip custom resources. I'll skip this part. Something that is new in container is CPU throttling. We are used to when you schedule more process on a computer and this doesn't have enough CPU, processes are scheduled less often. It's not true in containers because Linux has way more CPU than your container, and it will be able to run a few processes, like more process than the container has CPU, because the host, Linux itself, have more CPU. But the scheduler at some point will realize that it overscheduled CPU, and it will stop scheduling the process of your container. So this is called CPU throttling, and if a single PK lookup that usually takes 1 millisecond ends up being throttled, it will end up taking 100 milliseconds. So it generates a lot of tail latencies, and this is an uncomfortable situation in Kubernetes that you need to be aware of. We are thinking about this. We don't have a very good solution yet on this, but the Percona thread pool looks very attractive here. So if we have 10 CPU in a container, adding 10 threads in Percona, which means it will never go above 10 scheduling unit in MySQL, like looks quite appealing. And there's a link if you want to know more about CPU throttling. I will skip the challenges around automations, except the last line. Like, at first, our MySQL upgrades were a variable in our Docker image. So when we want to do a MySQL upgrade in 5.7, we change the variable, we reschedule all our pod. We call this deploying, rolling restart, everything like is rescheduled, and then a new Docker image start with the new MySQL binary, and then you hope that everything works well for 3,000 databases. It never does. There's always one key space that has a trouble. You need to roll back, and you hope that your binary and place downgrade will work. It was working mostly in 5.7. It's not working in AO, so we cannot do that anymore. So we build full automation for our upgrades. So what we do is we spawn a new replica set, a new set of pods with an upgraded image, running MySQL, replicating from the primary, and then we reparent to these and reparent back to rollback. And so we are able with that to control upgrade key space per key space. And this has worked well for us. And we needed to roll back sometimes. So insert unduplicate key update behavior changes some in one specific MySQL version that I don't remember. So always have a rollback story when you upgrade stuff. And this was quite a big investment in our automation, but now we have it and it's working well. So now that we've talked about Kubernetes, MySQL, Percona Server, we're getting at Vitess. So Vitess is a great middleware for running MySQL. I do not use the word scaling on purpose. For me, Vitess is a middleware for running MySQL. It's not necessarily the scalability of the data plane that I like in Vitess. It's the standardization of the control plane. So the control plane in Vitess allows you to automate a lot of stuff, do reparent, do backup, the same way in a very similar way across companies. And so it makes people, like, if you hire somebody that knows Vitess, they will be operational on your infrastructure very quickly. If you have all different scripts, they will have to learn your script, improve your script. And this is nightmare. Like, we don't like this. So running Vitess, for me, the most interesting thing in running Vitess is about making operations of MySQL standard. So some features are missing. We're going to talk about this. Upgrades are complicated, and we got to talk about sharding. Some people have already read this sentence. I will read it again when I will get to the sharding slide. So if you start to deploy Vitess, I would advise you to use your fork of Vitess. Fork Vitess, even if you don't have any patches, compile it yourself and run your binaries. Sooner or later, you will need something new in Vitess, or you will need to merge a community patch in your fork, or you will ask for a feature in Vitess, and the Vitess people will ask you, would you like to contribute this? And if you have Go developers, you want to be able to do that. So we do that very often. So our fork of Vitess is useful, and you should probably start your fork yourself if you deploy Vitess. Also, maybe something that you want in Vitess will not be done in Vitess, and you might want to do it yourself. So there's a weird thing happening to some of our VT tablets. They sometimes we thought it would be fixed in V14, but it is not. Like, now that we're to V14, we've realized that it's still ooming. So there's a buffer in Go somewhere when something produce something in the buffer and the consumption is not fast enough, the buffer grow unbounded, and our hypothesis is that it ends up killing, like Linux kills the VT tablet. It happens for us with extra backup. When the backup is able to read data from this quicker and it's able to push data out of the network. And it also happens to cross-shard query. So the VT gate ends up sending a query to 10 shards. 10 of shards returns a lot of data to the VT gate, but because this is funneled to a single VT gate, the buffer grows. And then the VT tablet ends up being killed. The container restarts very quickly, but it's annoying. Yes? Okay. Well, we have to talk. Like we see VT tablet ooming, especially on replicas when we take an extra backup, but also in some cross-shard queries, mostly run by devs. Like they craft a query that returns more data than they think it should, and then it ends up killing the VT tablet. Something about Vitess also is that the data plane of Vitess really isn't lean. So a query goes through the VT gate and then through the VT tablet, arrives to MySQL, like it's okay, a query arrives to MySQL, it's parsed. Data is returned. This data flows again in the VT tablet, is parsed, is encrypted before being sent to the VT gate. The VT gate decrypts that, parse it again, and return it to the application. So a lot of CPU is sent in this old stack. This is the cost of Vitess service discovery and of many of the Vitess scaling features. So it's okay, like we happily pay this cost, but some people that really wants to do CPU optimization might not like this, and they might want, or they might choose to still use Vitess, but without the data plane. And then they would connect themselves to MySQL, but they would use the control plane of Vitess to standardize their operation. And this is basically why I'm saying the thing for me that is important in Vitess is not the data plane itself, it's standardizing the way you operate MySQL. So sharding, I will read this sentence: easy, transparent, efficient, resilient, and general purpose sharding. For me, it's a myth. You cannot achieve all these things. Mostly, you cannot be transparent and resilient. You cannot be transparent and efficient. And in Vitess, sharding, an unsharded key space going to sharded is a project on its own. Like there are tables in there that you will want to keep unsharded. So the first step here is to split. All the times we use the features of having pin tables in sharded key space, for us, it triggered bugs in Vitess. We were running V5, but it was painful for us. So I would advise you to move away from these things of a pin table in a key space, in a sharded key space. Make all your shards identical, don't keep one table with data in a single shard. Like have a different key space for that. Resharding is easier, but we had problem resharding in V5. We had to patch our fork of Vitess for that. We haven't attempted to reshard yet in V14. We're in V14 only for a few weeks. And developers have a very narrow mental model of query execution, even in MySQL. So imagine their mental model of a distributed query execution in the VT gate. Like developers, they think they write a single query that will end up on a single shard, but it ends up being a cross-shard query. So all this is complex. You will need to help your developer. So transparent sharding here is complicated, both from an operation and a development point of view. And abstracting sharding brings all sort of reliability and efficiency problem. Like you can think of an application doing only primary key lookups. Yes, it's easy. This works well with Vitess. But if you have an application that needs to do a gazillion of PK lookups, and then you start batching your PK lookup in an in clause, well, this in clause with 100 PK will be a cross-shard query. If one of these shards is slower than the other, well, your query will be at the speed of the slowest shard. So it's not efficient. You end up tail latency ends up propagating. Tail latency propagate. So to be efficient here, the application needs to be shard aware and organize in clause according to shards. But this is not transparent. So in this case, the delivery of a transparent sharding to be efficient is missing right now. So if you go into Vitess, I would say that be willing to leak sharding abstraction to your application. Don't be naive that you will be forever able to hide sharding from your developers. I'll skip the fact that we're working on quality of service and circuit breakers are breaking with sharding. And the upgrade. So this is my last subject about Vitess. Vitess is an improving software. Its cadence of version release is 3 versions a year with an official upgrade path only from N to N+1 and being only supported for a year. So by the time you've upgraded, you're basically running like 6 to 9 months, and then you need to upgrade again if you want to stay maintained. So either you run unsupported or you constantly upgrade. And running an upgrade race isn't fun, and being unsupported isn't fun. So like, this is not cool. We need something better. So HubSpot was running Vitess 5. We upgrade in a single go from Vitess 5 to Vitess 14. And it took us a year. But now we have the tooling for that, so we hope that our next upgrade will be easier. So the way we upgrade is we had our initial Vitess v5 installation, and we used the cell concept of Vitess to build a whole new cell on the side that was Vitess 14. So it had VT gates, it had VT tablets, it had MySQL replicating from the v5 cell. And at that point, like, we have our new v14 installation only with replication traffic. And to upgrade the VT tablet, we reparent from v5 to v14. And so at that point, we have a VT gate v5 talking to a VT tablet v14. This is not supported. We had to patch it in our fork to make this work. If we're happy with this, we move forward to moving the application from the v5 VT gate to the v14 VT gate. If we're unhappy, we reparent back on the other side. So this is, again, a full upgrade that has a rollback at any moment. Like, the rollback of going from v5 to v14 is a reparent, and a rollback from the VT gate v14 to the VT gate v5 is a DNS repointing. And we needed this rollback because sometimes when you upgrade, queries are slower, and we needed to fix a few things to make this work. Like a repeated learning, when you do something, always have a rollback plan. So as a conclusion, after 5 years, HubSpot is happily running Vitess and MySQL in Kubernetes in production. Obviously, automation is never finished. So you will always, even if you go to Vitess and Kubernetes, you will always work on your automation. There's always things to improve there. For us, Kubernetes is mostly handled. Like, Kubernetes is fitting our needs. We're happy with it. We keep working on our operator because we want to run our own Kubernetes operator. MySQL and Vitess are good, but they could be better. Like, neither of these two technologies are fully matching our need right now, but they are evolving. So like, we keep running Vitess and MySQL, and we're committed to Vitess, and we will continue investing in it. Our learning, like, we're running 3,000 database, failover automation, and all automation works well. The Vitess people are available in the Vitess Slack, so there's a great community in the Vitess Slack. You should join if you're interested in Vitess. Upgrades are an area of improvement. Some queries, some features of 8.0 are not yet supported by Vitess. I think it will be soon. And as usual, best practices, like, stick to the best practices, upgrade, test, most important, have a rollback. So in my slides that will be online, there's all the links that I refer. So HubSpot links about war stories that I blog about, bugs in MySQL and Percona Server, compression bugs. I need to blog about the latest rollback I need to blog about the rollback bug, but the bug is open. It's the 11.10.63. Other good references about MySQL foreign keys. And obviously, HubSpot is hiring, not only for MySQL, Vitess, and Kubernetes, also for Zookeeper, HBase, Kafka, and Elasticsearch. This is all Shweta's department. So you can come to me or to Shweta to talk about these. Other things that we do data related, we have metrics, logging, and analytics. And like we have a lot of other cool tech for software engineer. So if you're interested, talk to us. And that's what I have. Last slide about data stuff at HubSpot. And like officially, we don't have time for questions, but it's the break. So I will stay here for some times if you have questions. Thank you very much. Can we keep the room for 5 minutes?
Absolutely.
Yeah, if you have questions, yes?
What flavor of Kubernetes do you guys run?
I don't know.
Like EKS, you run your
Oh,
own
no,
Kubernetes?
it's our own cluster. So we have people at HubSpot that are like dedicated to run our Kubernetes clusters.
What kind of file system do you use for like local?
So it's EBS. The file system, I think it's XFS.
Oh, yeah, I mean like EBS.
Yeah, and EBS is super useful for us for snapshots. Flo, wait.
For just like on EBS volume for on a new host or
So when we fail over to a new replica that has its own copy, its own EBS volume.
like if the pod gets rescheduled.
Yes, if a pod gets rescheduled, it keeps the same volume.
It's never like restored backup unless you spin up a new pod.
So when a pod crash and MySQL crash, a backup will be automatically triggered. When we add replicas to a key space, a backup will be triggered because it's an empty EBS. There's a few other cases that when a pod starts, it will kick a backup. But most of the time, we keep the data on an EBS volume between pod restarts.
Thank you.
Yes?
Yeah, so you say slicing possibly wasn't going to be supported with MySQL. Maybe it's for like server as well. Is it going to be supported by Percona Server?
This is a question for the Percona people. But I think there was a talk.
Specifically Percona engineering. Okay.
Uh,
Not us. All right.
Yeah. So I think there's an opportunity for Percona here, and yes, there's an opportunity for Percona.
But do they have a timeline when they want to remove everything?
So
It's not like, oh, it's going to go away.
so it's not written in a slide or any documentation. Like you hear this from the Oracle engineer. They mentioned this in a talk. So it's not just beer discussion. They mentioned this in a talk that wasn't recorded. But like the fact that bugs are not fixed, it already looks unsupported. A little like InnoDB, like table compression. Like the bugs are not fixed on this feature. So it's a feature in MySQL that like if you need it, you use it. But if you don't need it, stay away from it. Sadly, it looks like MySQL, Semisync is heading this way. I wished it wasn't, but it.
Because we're thinking about migrating to Semisync, which is still far way off. But we don't want to migrate to group replication. Probably.
You don't like group replication again.
We can use it,
Yeah.
but I'm not sure what the effect of it will be.
What? Yeah. What do you think of too complex and hard to troubleshoot? Yeah. You don't know yet. Okay.
Well, Jay and Weather, go ask them what's the Semisync. The answer from that.
They will like.
Give you that answer.
No name calling, but there's overlap between the name you mentioned and the voice I heard about Semisync not being supported.
Do you have any timeout to revert to asynchronous, like if Semisync kind of?
I think the way like by default, if a transaction is not acknowledged in 10 seconds, MySQL will go async. I think it's a bad default. It should be infinite. And like in 10 seconds, you already have a pileup on MySQL. And at that point, there's probably a DBA that will be like woken up or orchestrator that will fail over. Yes, and also like this happens in a network partition, or if you run out of replica, two things that should not
You just prefer to fail the write.
Yes, like if you're not able to persist the write, you fail the write. Yes, it's like we're handling data. We don't drop data on the floor. Yes.
So, okay, so you upgraded from 5 to 14, And why don't you, in the future, why don't you do the N plus, like, what do you migrate from N to N plus 1 always?
So we will probably skip versions again. Like maybe we'll upgrade from V14 to V18, 19, something like that.
Yeah, because the thing is that if you upgrade from one version to the version after, because it's always going to be compatible, it's like we ensure that
Yes.
any version of this is always going to be compatible, so that migration or that upgrade to be always equal.
Well, yeah, but the problem is that for us, an upgrade project will take more than 3 months in all cases, because
By then you have
and then you release a new version. So basically, PlanetScale and Vitess is releasing too many versions that we cannot keep up, and this is what I call an upgrade race. This is unsustainable. And if for any reason you need to focus on something else because the team that was supposed to do upgrade ends up focusing on upgrading to MySQL 8 as an example, and then you stop and then you're 3 versions behind, and then basically like trying to get back on this upgrade race doesn't work.
Because I know in PlanetScale we've added some, because PlanetScale has the same issue of upgrading this version of MySQL that you have Vitess clusters and collections. And like this was what I was like, I wonder how they're. Yeah, so like nowadays you have a bunch of automation in there.
We can continue the discussion at. Are there questions or? Okay. Or as the room, like as the people, I will remove the microphone and thank you.